consciousness is the way to transform, is what actually transforms syntactical information into semantic information, and vice versa. That would be my workable definition of consciousness. Now, in other words, it would be like what converts symbols into meaning. But now, meaning cannot be another symbol. Meaning is something different than a symbol. And as you know, computers, physical structures, and so on are simply transformers of meaning of symbols into other symbols. So a computer takes a symbol, works on it through an algorithm or whatever, transforms it into another symbol. But the crucial transformation from symbol to meaning requires consciousness. The meaning that I mean is qualia meaning, is feelings, is comprehension. In fact, meaning has structure. It's not just meaning. It is a structure. In fact, comprehension is finding meaning within meaning. So it's a recursive structure, and therefore comprehension is like finding long-range correlation between the various meanings that are connected together. So artificial intelligence claims that some artificial intelligence workers claim that it will be possible to make a conscious computer. And I claim that that is not possible based on the definition that I have given of consciousness, because a computer simply transforms symbols into other symbols. In fact, Max would be right to say that physical reality is mathematics if, in fact, we didn't have consciousness. Because mathematics is a symbol manipulation, and physics will be described simply by symbol manipulation, and there will be nobody conscious to actually feel anything or have any experience in that world. So, to me, ontology resides within the meaning aspect, the conscious aspect of reality. Now, I'm working on a beginning framework to explain more about this, what I can speak now because I only have a few minutes. It's called CIP framework. And I believe that we have a very good theory of the cognitive observer, in other words, a conscious observer, and how this conscious observer, in fact, relates with physical reality in a way that implies an interaction between two spaces, the space of consciousness and the space of information, which is the space of symbols. Thank you.
Thank you.
Okay. So I'm tempted, well, I already got a chance to talk about consciousness the other day. I'm tempted to say something about IIT, but maybe that'll come up in the discussion. Instead, I thought maybe just say something general about why physicists and cosmologists ought to care about consciousness. I mean, I see attendance is slightly down at this session, so there's a variety of opinions on this. Janan gave a very nice talk this morning on why physicists don't need to worry so much about the hard problem of consciousness. And I'm inclined to think there's something to that. I think, well, if you're a very ambitious physicist who wants to see physics as giving a theory of everything, then you better have something to say about the hard problem, how all this will explain consciousness. Or if you've got the strong kind of view where observers are going to play a causal role in physical dynamics, then you better have something to say. But I think other than that, then maybe it's right that physicists and cosmologists don't need to get too caught up in the philosophical arguments about the problem of consciousness. But I think it would be a mistake to conclude from that physicists and cosmologists shouldn't care about consciousness in the sense of subjective experience at all. I think at least the kinds of physicists and cosmologists who are interested in the role of the observer, which is something that came up a lot at this meeting. I think people who are interested in that really do have to think about consciousness in the sense of subjective experience. And the basic reason is that, well, I mean, the central role for the observer that almost everybody agreed on here was that it at least plays an epistemological role. We've got certain evidence, and our physics has to at least be able to explain and be consistent with our evidence. And our fundamental evidence is the evidence of subjective experience. That's the one thing that we have to save the data, save the direct evidence, it's subjective experience that we have to save. So this comes out, I think, in a number of ways in the debates at the conference, say the debate over Boltzmann brains. The kind of Boltzmann brain that we worried about, the kind of Boltzmann-like improbable scenario that we worry about is the kind of scenario that reproduces our subjective experience. A Boltzmann neuron is presumably not going to be a problem for our theories if it merely predicts the existence of Boltzmann neurons. Why? Because we don't think Boltzmann neurons are going to have the kinds of subjective experience that we do. Boltzmann brains are a problem for our theory precisely to the extent that we think that those Boltzmann brains will have subjective experience. If your theory of experience says that you can have brains of that form without experience, then it's not a problem for our theory. So in the debate the other day about whether you need Boltzmann solar systems or Boltzmann brains, I think Alan said, I think we only need the brain because that's what we need to save the evidence. That's relevant precisely because it's going to reproduce subjective experience. Now in that case, it's like, okay, so that needs certain claims about the connection between physical processes and experience, like a brain would pretty plausibly duplicate our experience. And maybe that's not a strong claim, but it's a claim about the connection between the two, very relevant to assessing the role of observers in our theory. Likewise, in quantum mechanics, where a lot of people see as one of the major problems for many interpretations of quantum mechanics, how to reproduce our standard observations of the physical world. And once again, what really needs to be reproduced is to show how quantum mechanics could give rise to subjective experiences, like this one. How in the quantum wave function, for example, as a challenge, say, for the Everett view, how is it in this Everett-like quantum wave function you get experiences like this one? One way to do that would be by showing you get a brain like this one and an environment like this one and everything else in the world. But the minimal thing that theory needs to do is to get experiences like this one. I think at that point, again, thinking about the connection between physical processes and subjective experience is really vital. In fact, in a book I wrote about 20 years ago, I tried to defend the Everett view by arguing that in an Everett-style wave function, you'd implement every computation that would be implemented in a branch of the wave function by itself, and then combined with a separate claim that reproducing the right computation will give you the right subjective experience. That was meant to help solve the problem for the Everett view. How can you make it consistent with our observations? And maybe that was right, maybe that was wrong, but that's just a general instance of the fact that in order to argue that these theories are going to, what you need to do to save the phenomena is to make sure these theories are going to be consistent or maybe even predict our subjective experiences. To think about that, you at least need to think about the connection between physical processes and experiences. That doesn't mean solving the hard problem, but it does mean at least giving some serious thought to consciousness.
Well, that beautifully segues into some of our remarks later, but let's thank David for those comments. So the meeting organizers have always asked the moderators to let sparks fly in these panel discussions, and I'm finding that a little tricky here because it's such an IIT-heavy contingent. So I'm going to rely on the audience when we get to audience Q&A in a bit to really pound on these theories and ask your tough questions.
You're saying this is not a random sample of consciousness researchers?
Yes, I think there's been a function that's weighted this in a certain direction. But there are two lines of questions I'd like to develop before I do open it up for general comment. And the second will actually concern some of your remarks on the connection to the other themes of the conference. But first, I'm noticing that a lot of people are coming to IIT really maybe even for the first time today, or it's an unfamiliar theory for them. So there's maybe some IIT 101 that would be fun to get into. And one question that I've always had about the theory, and this is really for anyone or everyone who's involved and done work on IIT or thought about it, how does it connect? How does this higher level of abstraction, and this is very much in the spirit of what Janan was saying, connect to the dynamics? So what is happening when I experience the world? What is actually going on in my brain to bring about the sensations? And when I become conscious of something, how does that occur according to the theory? And I think, Giulio, we're all looking toward you.
So I had one slide showing a network with units off, connections among them, units functional, and at a fixed point, so that that network will stay there like that indefinitely. So in some sense, nothing was happening. And yet IIT predicts that network will be conscious. So nothing needs to happen in any sense. What matters is what exists. So it's being versus happening. And this connects a little bit to one question that was raised by Carlo and not answered, which is one of the difficult things to understand about IIT. So IIT tells you that if you take a system, so a network of 3 simple binary elements connected in a certain way would be an example, and you want to know what actually exists there, you need to unfold its full cause-effect power. That network in that state, at T0, so to speak. And of course, Carlo came up with a question, which is a natural question to ask. So you are telling me, if I paraphrase you correctly, you're telling me that something is what it is by how it constrains, so to speak, the past and the future, its own past and future, or rather its inputs and outputs, I would say, and that what it's doing right now doesn't matter, okay? Now, it's not exactly that it doesn't matter. It matters enormously. It has to be in a particular state. But what something is defined by its causal power, not by what is happening or what it's doing. And one very simple way to at least think about what that means is take, again, 2 simple logic gates. Take an OR gate, which is on, and an AND gate, which is on. Just like that, okay? And then ask yourself, what makes something as a being an AND gate versus an OR gate? They're both on. They're both gates with 2 inputs and 1 output, okay? To find out what it actually is, it's not enough to look at what's happening when they're both on. It's not enough to look at what might happen later, okay? What you need to do is figure out their cause-effect power, and when you perturb them in all possible ways and look at what they do, you can see then that one is an AND gate, the other one is an OR gate, defined based on its constraints, the constraints it poses onto itself. So the state of the system matters in the sense that it provides a further constraint in addition to the connections. It says this set of connections in this state constrains the past and the future in the following way. And that you need to do to figure out what actually exists.
I can just add a comment on this with my physics hat on, which is I think we physicists need to be a bit more humble when we interpret observations of things, because we usually naively think of the experience of us seeing something as actually experiencing what's out there, which is clearly nonsense, because I've had some very interesting dreams where I experienced being in a room and seeing people, even though there was absolutely no sensory input at the time. So we know, and Giulio likes to emphasize this, that even that there are certain states of information processing in our brain, whether IIT is right or wrong, that feel subjectively like there's an outside world. So as physicists, it's pretty obvious that what's really going on is our sensory organs and so on, they are constantly taking in input and then using that to keep updating this internal world model. So it doesn't just kind of hallucinate on its own like when you're dreaming, but it tries to correlate with what's actually happening out there. But what we're fundamentally experiencing when we say, I observe the dial in my measurement thingy to be in position 7, is something in our head.
Maybe I can bring in Masafumi and Larissa on this as well. Let me try to be more precise. Suppose I see a rose, or how do the qualities of the rose leave an imprint in my brain, according to this theory? How does it change my stream of consciousness?
So your system that forms the major complex, which is what we call the substrate of consciousness, is not isolated. It has inputs, and when we calculate things, we take them as background conditions. So in the calculation, they're fixed, but of course they can dynamically influence the system. So what would happen is I show you a rose, it activates your retinal neurons, it activates some neurons in your color areas, and everywhere. And so the reason that you experience a rose is not that I showed it to you, but that all the right neurons change their state to the state of seeing a rose, and that state of this neurons constrains where they probably came from, so what the probable inputs were for this neurons, and it constrains what probable effects they will have. And all these constraints form this conceptual structure where part of that structure corresponds to the rose, and the rest of the structure corresponds to the rest of your experience. So that would be the conceptual answer.
So, and likewise, Masafumi, when I'm conscious of being conscious, how does that state of the network how is it communicated to the network? How can the network respond to it itself in that way?
Conscious of being.
Yeah, it's kind of a higher order consciousness. It's not just an external stimulus that enters the network. It's the property of the network that has to enter the network. How does that happen?
How does it happen? I don't know, but yeah, so to be conscious, actually that the system has to first observe actually itself. And that part corresponds that the system kind of determines the cause. And also the system, after observing itself, system has to do something. That part is a kind of effect, responding to some cause. And both need to exist to be conscious. That is the IIT theory.
So, Federico, please.
Yeah, what I find difficult to understand is whether phi is a measure of consciousness or simply a measure of the complexity, holistic complexity of a physical system that could support consciousness. And those two concepts are very different. So I don't see how we could call phi consciousness or qualia.
Should I take this?
Yeah.
Okay. All right. So this is something that happens many times to many people, especially if you give a 20 minutes presentation, but even with an hour. And even sometimes after reading the papers. So it boils down to, here is a measure, this measure of phi, which is interesting mathematically maybe, and Mark showed that is actually not completely mistaken maybe, and so on. And it's some kind of measure of complexity, and then there is this giant claim made that should be the quantity of consciousness, okay? But first of all, let me say there is more than that. As I say, this is a conceptual structure, which is an infinitely more complicated thing than phi. It's not a single number, it's a giant structure that is supposed to correspond to the quality, particular experience you're having. But even augmented by the quality, it seems like there's this big claim being made. Why would that be the case? What is typically forgotten is what I spent roughly 30 seconds about, which is the axioms of the theory. So it's a key thing in IIT. In fact, it is the fundamental thing at first. The first step is always the most important step. You don't start from the physical world, develop some kind of measure of complexity and say, maybe that's consciousness, okay? It would be nice if it were. You start from consciousness itself. That is the data that David says you cannot throw away. Your own consciousness. And you say, what are its essential properties, the ones that are true of every experience? Those are the axioms. Those axioms happen to be those 5, I think, after very long consideration. And then you say, well, the physical world, which is a postulate from within consciousness, let's remember that, a very good postulate, but it's a hypothesis that we make from within consciousness, has to support those properties that consciousness has to begin with. So it's not a measure that one then develops and claims it might have something to do with consciousness, but it is consciousness that leads directly to derivation of that measure.
So I very much admire this this feature of IIT, that it starts with consciousness and kind of reads off, kind of deduces, okay, let's have some axioms of consciousness and let's just figure out the mathematical properties that a physical system would just have to have in order to have those features of consciousness. But I think this actually has to do a lot of work for the theory, given that the empirical, it's so hard to measure phi and measure consciousness. I think the empirical support is, fairly sketchy. And so this, I think, is the big pillar of support for the theory. So it does mean, I think, that we need to pay a lot of attention to those motions early in the papers and the talks where Giulio goes from the axioms to the postulates to the mathematics, because that's very much playing a load-bearing role. And I guess one point where I'm just a little bit skeptical, I like the axioms, but I think, at a certain point these axioms get turned into postulates and they get turned into mathematics, and it's not quite transparent, all the steps from the axioms to the postulates to the mathematics. You get the sense that something is being slipped in, some extra highly specific content is being, for example, slipped into the mathematics along the way. So all I'd say is, given this support for the theory, which I like is a kind of transcendental deduction of how great for a philosopher, how the physical world would have to be to support consciousness. But you want to pay very, very careful very careful attention to how those steps in the deduction go. And you wouldn't be all surprised to find that another researcher, Tononi Star, had ended up in a very different place from a very similar starting point.
But David, can you be more specific about this kind of explanatory gap the theory has between the axioms and the other levels, so they have something that they can respond to?
It comes up in a few places. One place where I think it really comes up is in the principle of exclusion. So how do you state the axiom of exclusion?
It is consciousness contains what it contains, not less, not more, and it runs at a space-temporal grain. It runs not less, not
So
more.
prima facie, that's a principle about a given subject has a state of consciousness, which is one very definite state of consciousness. It's got boundaries. It doesn't contain other things. Somehow that gets translated into a principle about within a given physical system, if there is a subject with a certain degree of phi and another system with a certain degree of phi and another system with a lower degree of phi, then only the first system is conscious.
Subsystems, right.
And the subsystem is not. So somehow we've got a principle about subjects having definite states of consciousness, now to a principle about systems supporting distinct subjects. You might have thought, okay, well, in principle, you could have had two different subjects there, both with definite states of consciousness without doing anything to contravene the exclusion axiom that subjects always have a definite state. So we've moved from this single subject principle to a cross-subject principle in a way that looks, I think, to many people as if something new has been slipped into the theory.
Not really. It's a good point, but since you bring in transcendental deduction, meaning Kant, I'm going to bring in the principle of sufficient reason, therefore Leibniz. Okay, and we'll see who wins between Leibniz and Kant. But having said that, so exclusion is in fact perhaps the most difficult axiom of the theory, but it is, yes, based on a single subject. So, but what does it say? Essentially, it says consciousness is definite. So definite means it has borders, things are in or out. And it could be interpreted as if it were saying there is only one experience that is being had, but it only says, really, my experience is definite, it has borders. When you move to the postulate in the translation, and believe me, there is a lot of work in how to do that, and it is indeed a fundamental issue to make sure that that work is not cheating, okay? When you move there, the idea is, so if existence is cause-effect power, consciousness exists, physical substrate must have cause-effect power. If intrinsic existence is cause-effect power on yourself, if composition is the parts of cause-effect power, if information is a specific cause-effect power, not generic, if integration is its cause-effect power of one entity, not two, and so on. Exclusion means this cause-effect power must have borders, must specify a cause-effect structure with borders. How do you find the borders? So it must have them, okay? And since existence is cause-effect power, at least physical existence, the only way through the principle of sufficient reason, if you wish to find the borders, is to ask what exists the most. And that is the only existence-based way of getting the borders. There are no other ways. So while there is still work to be done to sort of prove the uniqueness of the derivation of the postulates from the axioms, it's not really proven. I think much of the effort has precisely been that, mathematizing those and making sure that we have just exactly the right set of axioms and just exactly the right set of postulates that uniquely translate those axioms. But the key here is cause-effect power.
But given that I'm the only non-supporter of the IIT in this,
I'm agnostic.
I'm agnostic.
at least I have questions. In other words, I mean, I appreciate the theory, and I really think there is a major step forward in understanding the nature of consciousness. Don't misunderstand me. But I have issues with it, and I would like those issues to be clarified.
Can you be specific? What is an issue?
The issue is the one that I mentioned earlier. basically, if you postulate the existence of consciousness, and it's postulated in your axioms, then how can you claim that consciousness emerges out of a physical system? It's already postulated there. So all that can emerge is what that physical system allows to emerge of something that already exists. So consciousness has to be a primary aspect of nature, isn't it?
Yes, and it's actually our starting point that consciousness is the one thing that we know and the one thing that we know exists. And maybe the way to understand this derivation is that the primary thing is consciousness. And through consciousness, because it has structure, we postulate that there is a physical world out there that is the reason for the structure in our experience. So then we know that there is a physical, or we inferred that there is a physical world. Now we take all these properties from consciousness and we basically project them onto this inferred physical world, and we pick those parts of the physical world that have the properties to correspond to those characteristics. And so we're not saying that, so you can't make, you can't then go and say, oh, all that we're base our theory on is that we identified some things and they give rise to consciousness. No, we had consciousness and we project down, and this is the set of physical substrates that we identified to have the potential to give rise to consciousness.
So as far as I can tell, IIT is completely consistent then with Federico's claim that consciousness is a fundamental aspect of the universe. Through that lens, it would just be the phi to consciousness principle would be regarded as something like a fundamental law that connects consciousness to other principles. I take it it's also consistent with a reductionist view where all there is to consciousness is integrated information. But as far as I can tell, the theory is consistent with both views.
Well, hang on, Federico.
no,
Max
I'm
has
not-
been patiently waiting.
I just wanted to make an analogy to inject both some caution and some optimism into this. So I want to make an analogy between two different subjects, which both start with CO, both of which I've worked a lot on in my career, and both of which started out being extremely controversial and branded as flaky by many. I'm referring to cosmology and consciousness. So in the checkered history of cosmology, it used to be largely derided as philosophy only. Sorry, physicists often use your wonderful field as an insult, and not much progress was made for thousands of years. Cosmologists were called by a famous physicist as people who were were often wrong but never in doubt, and a lot of very compelling sounding arguments based on principles and axioms and so on were made for example, that ultimately had conclusions that were completely wrong, such as that our universe should be static and not be changing. Even Einstein fell into that trap. What was it that changed cosmology into a more respectable science? Now, it was ultimately data. We'll get back to that. So, in other words, there were a lot of very nice sounding predictions, but they were testable. And most of them now are in the dustbin of history, and what survived we take very seriously. The reason I like IIT so much is not because I'm convinced that IIT is correct. No, I'm not convinced of that at all. Maybe it's correct, maybe it's not. What I love about IIT so much is it actually makes testable predictions. And just like cosmology suffered a dark age, very, very long period of time when there was basically no data, you could drink beer and speculate, but there was no measurements. We got all this wonderful data, and now it's more scientific. I feel we're on the cusp of exactly the same thing happening with consciousness. There's this avalanche of high-quality data about what's happening in the brain from outside that you can compare with your subjective reports and begin to test these things. So I'm ultimately going to take a very hard-nosed physics approach to this and only be convinced, not just because someone has eloquent arguments, but because testable predictions are tested and found to be valid.
A cynic might say that it's a beautiful property of the theory that it's testable in principle, but actually extremely hard to test in practice. right? Because of it's so hard to measure phi and it's so hard to measure.
Right, but as I was arguing,
I think if it was easily testable, it might have been tested and refuted or refined.
right, but as I was arguing in my talk, I think we're actually on the cusp of being able to start making some real tests.
So let me start with a quick poll, because I guess every panel has to do the speed round. Will a theory of consciousness help us with fundamental physics, yes or no? You're not even allowed to say it's complicated. Yes or no?
I'll go to someone else first. Already said.
Oh, you can't defer it.
What's that?
Yes.
Potentially.
Okay.
Definitely.
Yes.
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 Okay. Actually, I'm noticing a cue there that I've been completely ignoring. So maybe we'll go to that, and I've got some other questions we can come back to if the queue is exhausted. So please.
Sure. It seems to me like my crude impression of this development of IIT, it seems like there's an impression that phi should be some sort of unique measure. But if I want to talk about the fluffiness of a sheep, it's not really clear to me that there should just be one measure of the fluffiness of a sheep. So especially in the arguments about whether or not there's a derivation of phi from the axioms, there's not been, in my mind, an argument that there should even be a single formula that we should be able to derive from the axioms. So maybe you could explain to me if there should be or if there's not, why.
I'll say one quick thing about this. Essentially, everything we've tried to do for many years is based on the notion that consciousness is the way it is, and therefore it cannot be arbitrary how it is instantiated and therefore measured. And it cannot even be done in 2 or 3 similar ways, like the fluffiness of the sheep. So, for instance, this means that when you actually choose the distance, is it Kullback-Leibler? Is it Earth mover's distance, as we are doing, okay? The whole exercise was actually in finding what is the right distance measure. It cannot just be some distant measure that more or less approximates what the consciousness is. Consciousness is the way it is, and we need to find the correct answer. There is only one answer, in my mind.
So how would the theory be falsified? If you put a cat in an MRI scan machine and see a positive phi, would that falsify the theory? Or how would you do that?
Now, if you see 0 phi in a cat, I would be worried. If I see a good amount of phi, I wouldn't be so worried.
What if it's Schrödinger's cat?
Yeah, Schrödinger's cat, it can be both ways, but whatever. The point here, though, is maybe David made a comment that, saying the evidence is sketchy, etc. As usual, in theories, there is a predictive aspect, and there is also an explanatory aspect. There are many things that IIT explains that are basic things. Why this piece of brain doesn't do it and this piece does it, or maybe not even prefrontal cortex does it, even it's a piece of cortex. All these are very basic facts, okay? And IIT has a principal explanation of them, but basically you find nowhere else. There are many other things like that. And there are also very specific predictions, which we won't get into, but I was briefly mentioning to Sean before that, for instance, one has to do with space. One very precise prediction of IIT, which are testing, is if you change the strength of a connection in this back part of your brain, of just some connections between neurons, it will deform the phenomenal perception of space. It will contract it, even though the activity of the neurons, the state of the neurons, doesn't change at all. That's a very counterintuitive prediction to most neuroscientists. The results actually seem to support that, psychophysical results. And another prediction is the one I showed you before, that an inactive but functional brain would be conscious, and that's, again, totally counterintuitive to most people. So I think these are, in the tradition of counterintuitive predictions in physics, something that you can actually test with IIT, and we are testing.
Before we go, Federico, let me ask you and bring you into this. Is there something you would like to apply as a test, a falsifiable test?
No, I'm not at that level in my development. I've been working for about 3 years on this in terms of real work. So no, I don't yet.
Very good. Please.
Another quick yes/no question for the panel. So, does consciousness exist at a more fundamental level than the space-time matter level? And there could be a more simpler level. So Max would probably say it's mathematical, the basic level. But the question is, does consciousness exist at a more fundamental level?
Great. Let's go down the panel.
Space-time matter, yes or no?
Yes, no, and no evasion this time.
At an equally fundamental level. Not at the more fundamental.
Okay, yeah, fair enough.
At the more fundamental level.
It's complicated.
No.
No.
Yes, I think. Yeah.
Yes, it's intrinsic existence as opposed to for somebody else.
So you need new physics.
We've all been behaving as if the number of consciousnesses in this room is equal to the number of people. But that's a very individualistic way of looking at things. It's often said that if you have a lot of people together in a room, the number of opinions is greater than the number of people. But it
Especially
could be
this
that
room.
it's less. And that whatever we have that distinguishes us from inanimate matter may be more like what Jim Hartle said the other day when he says that the whole scientific establishment or the whole of human civilization is just one igus, not a lot of different consciousnesses. And perhaps other less individualistic philosophies would pose the problem of consciousness that way. Now, my other thing is, I guess it's not a question either, but that Scott Aronson has criticized IIT as producing a lot of false positives, things that you wouldn't think are conscious that would have high values of it. So I guess that's something people should consider.
Let me just build on the first part of your remark in particular, and I'll direct this question to you, David. Is IIT vulnerable to a dancing qualia type of argument? That you could switch back and forth between levels and consciousness would fade in and out?
Well, here is actually one place where I think it might be vulnerable to that style of argument. Giulio's claim that a computer simulation of, for example, a brain on a von Neumann computer will have no consciousness because it has zero phi, whereas, say, a neuromorphic version would have high phi and so would have consciousness. I think you could imagine a gradual transition from a neuromorphic version to a von Neumann version where we kind of take the direct connections between neurons and route them through a CPU. I mean, the basic reason why the von Neumann version has zero phi is because there's a von Neumann CPU through which everything passes, and somehow that brings phi down to zero. But I think that one could have a gradual transition where we replace all these parallel connections by von Neumann connections gradually. The functioning of the system will remain completely the same throughout. Phi will, at least by Giulio's account, go from something very high down to zero. My consciousness will go from something very high down to zero. And the question is, well, what happens to my consciousness on the way? I'm presumably either going to have to wink out at some point. Well, that won't happen on Giulio's view. It'll gradually go down, despite the fact that my behavior is the same throughout. It's really hard to make sense of those intermediate states, these faded consciousness states where, I'm here behaving and even thinking normally, but my consciousness is fragmented down to just bits without me realizing. And we probably could do dancing qualia, which is going back and forth between the neuromorphic version and the von Neumann version, and consciousness switches in and out without ever showing up in my functioning. I find all those predictions extremely counterintuitive and best avoided if they can. So I'd much prefer a version of the theory that assigned high phi to the von Neumann simulation of a brain.
But maybe I can say something in direct response to the theory. So, a lot of people really like this idea of a group consciousness. But phenomenologically, we know about our own, and that has limits, right? It has borders. And so the way people think about group consciousness is typically, I want all of the people here to have a consciousness, and then maybe I want 50 people together to have a consciousness. But if you relax this exclusion postulate or the axiom that only maxima of consciousness exists, it's not just me and the group of 50 people. It's also me minus 1 neuron, minus 2 neurons, minus 3 neurons, minus 5 neurons. All these would exist. It's me minus a molecule. It's me minus... and so it's not just like, I excluded this one other possible consciousness. I excluded millions of ridiculous multiplications of my own consciousness.
Thank you.
So a fairly radical suggestion that's been floated once or twice in the conference is that conscious creatures don't follow the laws of dynamics as we understand them. In other words, you have to take account of their consciousness in order to predict exactly what they're going to do. I just wondered if we could poll the panel on whether they think that's like, what their credence is, what they think the chance of that being true is, and if they could say in a sentence why.
Well, I mean, it's at least a possibility I take seriously, given that I think there's a very good argument for consciousness being fundamental in nature. Once it's fundamental in nature, it'd be great if it could play a role. It's very natural to suppose it plays a role in the dynamics. I mean, the one place where it's most obvious to look for it to play a role in the dynamics is, of course, quantum mechanics, where traditional views suggest it, and people go left and right. Well, we've developed interpretations of quantum mechanics that don't give a role to the observer. Well, that's great, and I like a lot of those views. But hey, well, there are interpretations of quantum mechanics also that do give a role to the observer and consciousness. And I think we should at least be trying to develop those in analogous detail. 20%.
If you consider a loop of observation and action, then you have an understanding, which is equale, and that means that you can now generate a symbol that interact with other symbols in physical reality. Okay? Then you can get the information, the transformation of reality done by physical reality to the symbol that you inserted into physical reality. You receive that symbol, you convert it into a different meaning, and that means that you can now have a loop of action through the physical world that affects the physical world through the meaning, the increased meaning that you had through this cognitive loop. That's the way I look at it. But it's very, how to say, very coarse at this point, but it needs to be refined much more. But that's the way I look at an observational process. Is not an event, is actually a process. And there are loops that repeat and that increase comprehension.
Max, did you want to comment on the question as well?
Yeah, my guess is that maybe I'm a small minority on the panel, I think. My guess is that we don't need anything beyond standard physics, protons and all that stuff. And the reason for that is, by an analogy, I think we have many times in physics made the mistake of blaming our failures on invoking the need for some additional magic fairy dust ingredient. Before Newton, a lot of people thought that the reason the moon wasn't falling down, even though rocks did, was that somehow heaven objects had different properties than earth objects. And his genius was to do away with that extra fairy dust and realize that it was all just the same physics. Similarly, not that many hundreds of years ago, people thought the difference between a living bug and a dead bug was some extra life sauce fairy dust, whereas now you just think of the dead bug as broken. It's the same physics. And by analogy, I think it's very tempting to say that we need something extra to get the subjective experience, but I would love to try it our hardest first to see if we can explain it with just what we have. And it's exactly the same minimalistic principle of trying to avoid fairy dust that's led me to my most controversial view of all, which is this guess that there's no difference between mathematical existence and physical existence, because you can write down the standard model equations and a bunch of other equations and say that there's some magic extra physical existence fairy dust that you pour on one particular mathematical structure to make it somehow pop into being. And I think it's much more elegant if you don't need that either. You can just say, well, there is nothing extra and all the different mathematical things are equivalent. So that's my guess, the minimalist guess.
But then if you are consistent, you should not accept the postulate that consciousness exists before anything else, which is the postulate that exists in IIT.
For me, it's not a postulate. For me, it's just a direct observation that my subjective experience exists. And that's more primary than any of my other observations. The reason I believe that you exist and the reason I believe that atoms exist is a more indirect inference from my subjective experience.
Very good, thanks. Oh, wait, okay, no follow-ups just now because we have a line, but.
So this is something that David already began to talk about, and I guess it's addressed to those who take IIT seriously, even if they're not committed to it. And that is this issue of the claim that a von Neumann computer could not be, could not have a high value of phi. For those who think that, well, first of all, people could say whether they agree with that or don't agree with that, and for those who do agree with that, would they explain why the arrangement of things in three-dimensional space that we seem to be living in should be so critical to something which seems as more fundamental than that, of consciousness, if that makes sense. So David clearly didn't agree with the claim.
Well, I mean, it's Giulio's theory, so he can stipulate how phi works. But I've got to say, I would have thought there's at least a version there's a theory pretty close to IIT that allows a von Neumann computer to have pretty high phi. Because basically, my understanding of how the theory works is you can take a system and you can coarse grain it in all kinds of ways to figure out here are the units and here are the connections. And I would have thought there'd be a theory that would allow a kind of coarse graining so that all the points in the array outside the CPU are the units, and the CPU itself is just part of the causal background between the units. And on that kind of coarse graining would have exactly the same phi as a neuromorphic version. Now, maybe that's good for some reason on Giulio's version, but that's the version I would prefer.
That seems perfectly reasonable to me, but that's why I want to find out,
Well, so once again, a remark that we start from the axioms, not postulates of consciousness, because as Mark said, those are the ones that are immediately evident, okay, while everything else is inference. From there, if the translation is nearly unique, which we think is, then it follows then a von Neumann computer, we sort of recently proved this, cannot be conscious as such, only these minimal little entities. And we did exactly what David is saying. So we did all possible black boxings, the one that Larissa briefly illustrated, for this mini von Neumann computer. And it doesn't matter how you black box it, there are tons of possible black boxings, it never can do that. So that's a very, very strong consequence of the theory. Now, I will take this opportunity to get back to Charlie Bennett, who also brought up one question, which was this Scott Aronson question, okay? And it relates to your question about the 3D, or rather stick to 2D for the moment, structure of the actual physical world, okay? And is that in any way important for consciousness? So one issue that was always clear in IIT is that grids, physical grids, not mathematical grids, that physical grids, because IIT is physical in that sense, are a good substrate for high phi. And a stack of grids is an especially good substrate, so a pyramid of grid, whatever you want to call it. And so Scott Aronson is a good exemplification of the idea. He did it with van der Monde matrices and the error correcting code, but you have to do it physically, and the physical implementation of that is a grid. A grid has so low algorithmic complexity. It's such a simple thing that his gut feeling told him it cannot possibly be conscious, okay? Well, the evidence very strongly suggests, I showed you a couple of slides, that we, or at least the part of our brain that matter for our consciousness, are by and large a stack of grids. So think about that as evidence for the theory, not evidence against, okay? And these are data. On top of that, the structure of conscious experience also is consistent with what a grid does, which is essentially space. Okay.
Can I say
Please.
one more thing about so maybe the first way to think about it is that for the simulation, is that for IIT the implementation matters, not just the computation, right? So, and it's hard for me to understand why this is always so hard, because if you simulate water, the simulation is not wet, right? But for some reason, if you simulate consciousness, the simulation is supposed to be conscious, right? So why is that? Because people think that pure abstract information is what gives rise to consciousness. But IIT is a physical theory, and that the information in IIT is physical. So only if you have a physical thing that has states, those states constrain their past and future, and in that sense it's causal information. And you're not allowed to leave causal interactions out of your analysis. So the only way to get a mapping from a computer to what the brain is doing is by leaving out some of the physical parts of the computer. You're not allowed to do that because they're actually interacting, right? So we start with the actual physical substrate of the computer. And that is the basis for the causal analysis.
Larissa, just to follow up quickly, and then we go to Ian. This entire model that the team has developed about causal efficacy and cause effect power, do you think that has applications actually to maybe to physics, to understanding the hierarchy of levels of description in nature?
So, I mean, we have a paper about the causal complexity in discrete dynamical systems, for example, where we show that, for example, if you analyze all the elementary cellular automata, there is a relation. So the understanding the causal structure of a system can help you understand the system. And all these higher order interactions that are typically ignored when you just have your initial state and then you run the system, those higher order interactions are important to understand what the system is doing. So in that sense, even if you taken purely as a measure of cause-effect power, I think it can be valuable, yes.
So something Masafumi said a little earlier got me thinking, and I part of this is my ignorance of IIT, and so you can clarify. I wasn't sure if the theory required self-awareness or not. So my question is does it? And if it does require self-awareness, I would want to know, how do you measure that? So for instance, if you're Giulio and you want to find out if object X is conscious, how do you measure quantitatively the self-awareness? If it's not self-aware, then I would ask, why not? Because it seems like that could almost be part of the axiom of, if I take consciousness to be axiomatic, because, and Giulio's justification is because, and Max said, because I know I'm here, then that's a self-awareness thing. Like Max said, he's more aware of his own existence, his own consciousness, than he is of anybody else's. So.
What I meant by saying that the system has to observe itself, and that means that the system has to, know what is the past state based on its present state. That is kind of self-awareness, or it's not necessarily exactly equivalent to the self-awareness, but in some sense, the system has to know about its past based on its present. So yeah, in this sense, it is kind of self-awareness, but yeah.
But what happens if you get amnesia?
Amnesia, like no memory or something. So IIT does not require a memory, but it requires that it can specify the past based on its present. So it has to be some mechanism to, infer on its past. Yeah, that is necessary, but that is not necessarily equivalent to the memory, function memory maybe, or function self-awareness. But yeah.
Very good. Let's thank the panel for a wonderful discussion.